video part continuity or discontinuity, and video part 7. Let's do some problems. Study the continuity of f at the specified point in each of the following cases. Part A. Part A says f of x is a function defined, and we need to study the continuity at x equals 0. The function defined as f of x is equal to x squared minus 1 if x is negative, minus x minus 1 if x is positive. First, before we start studying the continuity, we should study if the function is defined over the point I need to study its continuity or not, right? So what do we have over here? We have x is negative, x is positive. In both cases we have their parts, right? So the function of x is defined at all negative numbers, all positive numbers, but it's not defined at 0. 0 is not in its domain. So this means f directly is not defined at x equals 0. What's that mean? Therefore, f is discontinuous. It's not continuous at that point. It's discontinuous at x equals 0. If we do the same thing, part B, the same thing, but at x equal 2. Let's study the continuity at x equal 2. Same function, f of x equal x squared minus 1 if x is less than or equal to 2, and minus x minus 1 if x is greater than 2. Here it's defined at 2 because we have or equal at 2. So let's start limit, right, of f of x. Let's start study the limit at the right of 2 and the left of 2. At 2 minus left of 2 is equal to limit. When x approaches 2 minus, this means it's less than 2, so we take this part over here, right? X squared minus 1, substitute instead of x its value, which is 2, so it's 2 power 2 minus 1, then we have 3, 4 minus 1. Limit of f of x as x approaches 2 plus, it's greater than 2, x greater than 2 over here, so the part we need to discuss is minus x minus 1, so it's equal to limit of minus x minus 1 as x approaches 2 plus, and instead of x we put 2 minus 2 minus 1, the answer is minus 3. We don't need to continue because directly we have two different answers, since the limit at 2 minus as x approaches 2 minus does not equal limit of f of x as x approaches 2 plus, then f is not continuous. F is not continuous, or we can say f is discontinuous. Either f is not continuous at x equal 2 or f is discontinuous at x equal 2. Part C. Okay, you have to be careful here, but part C is very nice, very important. F of x equal sine of x divided by absolute value of x. If x is not equal to 0, and 1 if x is equal to 0. This is important one. Okay, what is happening over here? Let's study that first to the left. What is happening, or to the right? So limit of f of x as x approaches the right of 0 is equal limit of sine x over absolute value of x, right? Absolute value of x as x approaches 0 plus. What's the mean x approaches 0 plus? This means x is a positive value. In this case, the absolute value of x is gonna be x, right? And that is 1. Limit of sine x over x as x approaches 0 plus is 1. Limit of f of x over as x approaches 0 minus this time, it's equal to limit of sine x over absolute value of x, but this time x approaches 0 minus. This means x is a negative value. I cannot say over x because what comes from the absolute value is a positive value. This means I have to multiply it with minus. So the answer is going to be minus limit as x approaches 0 minus of sine x over x. and this is 1, whether it approaches 0 plus or 0 minus gives me the same value, but we have minus here, so the answer is minus 1. This means, do we have continuity? We don't. We don't. F is discontinuous. Limit does not exist, right? Limit at x equals 0 does not exist because left side does not equal to the right side. Since limit of f of x as x approaches 0 does not exist due to two different answers from the right and from the left, right? This means f is discontinuous at x equals 0. At x equal 0. This is part D. This is part C. So now part D, also you have to be careful. It's x equals 0. We are studying f of x when of the function sine x over x, all in the absolute value if x not equal 0, and 1 if x equals 0. Here, let's see what's the difference between these two. First, first limit, right, of f of x as x approaches 0 plus or 0 minus, right? It's the same because it's in the absolute value. It's in the absolute value. Limit of f of x as x approaches 0 plus or limit of f of x as x approaches 0 minus. In both cases, they are the same, right? It's already equal to limit of absolute value of sine x over x as x approaches either 0 plus or 0 minus, which is absolute value of the limit of sine x over x as x approaches 0 plus or minus, which is equal to 1. Both cases equal to 1. So, f of 0 is equal, f of x when x equals 0, it's given as equal to 1. So f is continuous at x equal to 1. Part E. Part E is exactly like part 1. I will skip it. I just will give it to you like x equals 0. F of x equal 6x if x less than 0, and f of x equal x squared minus 4 if x is greater than 0. If that is given, so at x equals 0, the function is not defined, 0 is not in my domain, so it is not continuous. So since it's not defined, it's discontinuous at x equals 0. All right, let's make part F. Part F is the same, but instead of greater than 0, we have greater or equal to 0. Over here, this means we need to study the limit to the right side and to the left side, limit of f of x as x approaches 0 plus. It's when x greater than 0, so we are talking about which part with the x squared minus 4 as x approaches 0 plus. This means it's equal to minus 4, and limit of f of x as x approaches 0 minus, we're talking about the less than 0, so which part we have to take? Limit of 6x as x approaches 0 minus, then it is equal to 6 times 0, which is equal to 0. So the right side does not equal to the left side. Also, we have discontinuity at x equals 0. We don't continue our problem. We directly can say that f is discontinuous. Gx equal at x equal 1, we have to study the continuity of f of x if, right, of f of x if which is equal minus 3x if x is less than 1, and x minus 4 if x is greater than 1. Again, what's going on? Do we have f of x defined at x equal 1? No. So since it's not defined, then directly it's not continuous at x equal 1. We go to H, x equal 1, where f of x is equal to absolute value of x. Also, we have to study the continuity at the right, at the left, limit of f of x, which as x approaches 1 plus is equal to limit of absolute value of x as x approaches 1 plus, which is equal to limit of x as x approaches 1 plus, y absolute value of x is equal to x, because as x approaches 1 plus means I'm in the positive side, so the absolute value of x is equal to x directly. This means if we substitute 1 plus or 1 instead of x, we are going to get 1. Look what is the difference here. Do we have a difference? You have not to be confused. This is very important because we are talking about limit of f of x, which is absolute value of x as x approaches 1 minus. Some students, they get confused because instead of absolute value of x, they put minus x instead of x. And this is wrong because 1 minus is a positive value, right? So as x approaches 1 minus is positive value, so the same, right? And at the same time, if we say f of 1, which is absolute value directly of 1, we're gonna get 1, since limit to the right equal limit to the left equal f of the point, f of x as x approaches that point or equal to that point. This means it is continuous at x equal 1. We have continuity in this problem H. Let's check I. All right, let's go to part I. Part I says as x equal 1, f of x is equal minus 3x, as if x less than or equal 1, x minus 4 if x is greater than 1. Do we have a domain of definition? Is it defined at x equal 1? Yes, it is defined as x equal 1, so we can continue. Now, limit of f of x as x approaches 1 plus equal limit of x minus 4, because as x approaches 1 plus means x greater than 1, which is equal to 1 minus 4, which is equal to minus 3. Limit of f of x as x approaches 1 minus is equal to limit of this part minus 3x as x approaches 1 minus, because x less than 1, which is equal to minus 3 into 1, which is equal to minus 3. And f of 1 when x equal 1, also we substituted in this one here, so it's equal to minus 3 times 1 equal to minus 3. In this case, all of them are equal to the left, to the right, and at the point. This means x is continuous at x equal 1. Let's go to the last part, which is J. Okay, this is very nice. He wants me to check whether it's continuous as x equal minus 2, and we don't have f of x actually as function given. It's given as only by, it's not the rule given, it's given by a certain graph. This is minus 2, and this is plus 2, and this is the function. Okay, and he wants me to check whether it is continuous at x equal minus 2. What's happening at x equal minus 2? If x approaching minus 2 minus, I will write, we have to write, limit of f of x as x approaches minus 2 minus, limit of f of x as x approaches minus 2 minus, means from below minus 2. The answer is this point, right? The answer is this point. As x minus 2, what is y? Y is gonna be 0. And limit of f of x also as x approaches minus 2 plus, right? The answer is gonna be also 0. And f of minus 2 is equal to what? If x equal minus 2 directly, also y is equal to 0, so we have continuity at x equal minus 2. And of video, we'll see you in video part 8.